Hello, young math Padawans. It's Mrs. Angel with a lesson on graphing and writing inequalities. Before we begin, just a quick reminder, greater than does not mean larger, but rather more positive than, or on a number line, it means to the right of. And less than does not necessarily mean smaller, but rather more negative than, or to the left of on a number line. So to start off, I want you to think of a number that is greater than 5. In fact, I'm going to challenge you even more. I want you to think of a couple numbers that are greater than 5 and then mark them on your number lines. As a statement, we would represent this with a variable x, which means any number, the symbol for greater than, and 5. This statement is x is greater than 5. So what's the difference between the top statement and the bottom statement? The top statement is x is greater than 5. And this is what it looks like on a number line. All numbers that are greater than 5 are going to be to the right of 5. Notice here that 5 is not included in the solution set, hence why it has an open circle. It's circling 5 to show that this is where my solutions start. But 5 isn't greater than 5. 5 is equal to 5, which brings us to our second statement. The second statement is x is greater than or equal to 5, and you can tell the difference because it has half of an equal sign right underneath the greater than symbol. On a graph, you'll notice that it's almost identical to the top, except for now 5 is included in the solution set. So we're including 5 in our solution set because it is equal to 5. Now, can you think of a number less than negative 5? Here's the statement we used for less than negative 5. We have our variable x, which stands for that number that you were thinking of, the less than symbol, and negative 5. So again, what's the difference here? The top statement is the one that we just talked about, x is less than negative 5. This is an example of the graph. All numbers to the left of negative 5 are less, and notice that negative 5 is not included because negative 5 is not less than negative 5, it would be equal. Which brings us to the bottom statement, x is less than or equal to negative 5. And the graph looks almost the same, except for now the solution set does include negative 5 because it is equal to. So open and closed points mean something completely different. Open points are used to represent greater and less than, but not equal to. It's not included in the solution set. However, closed points are used to represent the greater than or equal to and less than or equal to symbols because they are also parts of the solution set. So now we have kind of a different question. 4 is less than what number? This statement, we now have 4 on the left side and our number x is on the right side. So we would read this statement as 4 is less than x, meaning my numbers x are actually greater than 4. So again, what's the difference here? Well, the top statement, 4 is less than x, means all numbers to the right of 4. 4 is less than 5. 4 is less than 6. But again, 4 is not included because it is not equal to. In the bottom statement, 4 is less than or equal to x, which is a very similar looking graph, except for now the solution set does include 4. So be careful when the variable or the number you're thinking about is on the other side, is on the right side of the statement, you have to think about these inequality statements a little bit differently. Our final question for this, 4 is greater than what number? Again, 4 is on the left side of our statement here, and 4 is the greater value, meaning the numbers x are actually less than 4. So in the top statement here, 4 is greater than x. This is our solution set. 4 is greater than every number to the left of it. 4 is greater than 3. 4 is greater than 2, 1, 0, etc. However, 4 is not greater than 4, which is why we have an open point. 4 is greater than or equal to x looks almost the same. 4 is greater than or equal to 3, 2, 1, and 0. But this time the solution set does include 4 because it is equal to. Looking here at number 1, we always read inequalities from left to right. So I'm going to start off by reading this as m is greater than the value -5, and that's what this means in words. So I'm going to start by identifying -5 on my number line. And what I like to do is I actually like to start off by marking down some solutions that I know for sure. What are some numbers greater than -5? Well, -4, -3, -2, all of these numbers are greater than -5. But not just those, also everything in between. Those decimals and fractions, those are also greater than -5. And it doesn't stop at the end of our number line. It's going to keep going all the way to positive infinity. But what about -5? Is -5 a solution here? Well, to figure that out, we have to go back to our original statement. Here, m is greater than -5. Is it also equal to? No. So since it is only greater and not equal to, we are going to use what's called an open point to show that my solutions start at -5, but -5 is not included. Looking at statement 2, again reading from left to right. Our numbers k are less than or equal to the value 1. Okay, starting off by identifying 1 on our number line. And again, I like to just fill in some possible solutions. What are some numbers less than or equal to 1? Well, I know 0 is less than or equal to 1, -1 is less than 1, -2, and so on. So in this case, it's going to be every number to the left of 1, and it doesn't stop at the end of our number line. It keeps going. Now, what about 1? Is 1 a solution here? Well, we have to go back and look at our symbol. Here, k is less than or equal to 1, so yes, 1 is part of our solution set, and we want to make sure we put a big closed point on 1 to show that it is included. -6 is less than our number p. So I'm going to start off again by identifying -6 on the number line and filling in some possible solutions. -6 is less than what number? -6 is less than -5. It's also less than -4 and -3 and -2. So all of the numbers that -6 is less than happen to be to the right of -6. Now, what about -6 itself? Well, to figure that out, we have to look at the statement. Is -6 less than -6? No, those are equal. So we're going to use an open point at -6 to show that this is where our solutions start, but -6 is not included. 3 is greater than or equal to W. All right, here's 3. Now I start filling in the blank. 3 is greater than what? 3 is not greater than 4, 5, and 6. 3 is less than those numbers. 3 is greater than 2. 3 is also greater than 1 and 0 and everything else to the left. 3 is the greatest of all of those numbers. But what about 3 itself? Well, looking at the symbol, it's also showing that 3 is equal to, meaning it is a solution, and we can represent it with a closed point. Here, R is greater than or equal to 1.5 or 1.5. Well, here's 1 and there's 2, so 1.5 is going to just be halfway between them. So here's 1.5. Now, what numbers are greater than 1.5? Essentially, everything to the right and all the way to positive infinity is greater than 1.5. But what about 1.5 itself? Well, our symbol does say it's also equal to, therefore we know that 1.5 is a solution itself and does deserve to be represented with a closed point. In our last example, negative 1.5 is greater than D. Here's negative 1, and here's negative 2. So negative 1.5 will be about halfway between those two. Okay, now negative 1.5 is greater than what numbers? Negative 1.5 has to be the greatest of all of these, meaning all of my solutions have to be less than negative 1.5. But what about negative 1.5? Well, this is the symbol for greater than, and nowhere does it say equal to. Therefore, we're going to use an open point here to show that negative 1.5 is where our solutions start, but they are not included. So when in doubt, when you're graphing inequalities, read the statement out loud. Think to yourself, what does this actually mean? And then the rest of it is actually pretty simple from there. That's it for today's lesson. I will see you next time.